Welcome, ladies and gentlemen, to our first live webinar, TechXchange. I am Daniela. I am working in the marketing department, and I will guide you through this presentation today. As the name TechXchange already says, our goal here is to give you insights in technology aspects of reciprocating compressors. So we are very pleased that you take your valuable time to join us today. Just have a look how many participants we have now. We are over 30 participants from many different locations. Great to see that. Please note that this webinar will be recorded. All your microphones are muted. Feel free to ask questions in the question and answer section, which you can find below on your screen. Our speakers today are Redura Müller. She is a regional sales engineer for the regions East Europe, Middle East, and Africa. And we have David Flood with us. He's responsible for sales and technical support related to rings and packings. Both of them were involved in the Revamp case that we will speak about now, and Redura will start with a general overview.
Thank you, Daniela. The case we would like to introduce here is from a well-known refinery and one of our biggest customers. And here in this slide, we see a typical oil refining process where reciprocating compressors are used in different stages of the refining. In this particular case, the compressors were used in the naphtha hydrodesulfurization process. There were 3 identical Ingersoll-Rand reciprocating compressors used in this dry-running hydrogen makeup and recycle gas service. The slide shows one of these compressors. Explaining a bit further on these machines and the process parameters, each compressor was a 2-stage 254 mm, that is 10-inch stroke, machine of Ingersoll-Rand type 2HHE. It was a non-lubricated compressor used for hydrogen mixed gas with a rated speed of 428 RPM and shaft power of 550 kilowatt. The compressor was compressed from a suction pressure of 17.6 bar absolute and suction temperature of 38 degrees Celsius to a discharge pressure of 62 bar absolute. The customer was facing lots of challenges in these machines. First of all, there was a tightened health, safety, and environmental, that is, HSE regulations in the territory, due to which they had to maintain all the equipments, including the compressors, leakage-free. Unfortunately, there was a high leakage of hydrogen, hydrocarbons, and hydrogen sulfide from these reciprocating compressors. Piston rod sealing system had a very short lifetime, causing high maintenance costs and low compressor availability. As you may see in the picture, there are several yellow tags indicating leakages and hence non-compliance with HSE regulations. Customer had taken lots of measures to solve the issue. Unfortunately, they did not help in the long run. In this slide, you can see the state of the compressor before revamp was carried out by Burckhardt compression. And in this slide, you can see the completely revamped compressor. It is only to show you the glimpse of the final revamp. A detailed analysis of the situation was carried out by the experts of Burckhardt compression. The main causes of the leakages were identified and suitable solutions were developed. One of the main concerns was the piston rod sealing system. So, our focus today will be on the oil wiper, intermediate packing, and main packing, which will be explained in detail by our colleague David Flood.
Thank you, Redura. So I am going to start with the oil wipers. The oil wipers are very important to a dry running system, because if you get any oil carryover into the main packings, you will get a slight mixture of oil and also wear debris, and this will completely wipe out a set of packing rings. So you will not get a good life. Also, of course, if you get oil coming out of the crankcase, that means it has to be thrown away. So there is an environmental concern there as well. And of course, the oil is not exactly cheap. You can see here a picture of the oil wiper that we installed in this compressor. And this picture is also from the manual, which Redura will mention again later. And within Burckhardt compression, we have a sealing system philosophy, which we call Redura. And that means that we design a sealing system with different rings doing different jobs. And that also applies to an oil wiper system. And I will show you some slightly better pictures of these components here. So here we start off with a pre-scraper. And you can see that it is a very basic, simple ring. But what this ring does is it prevents 90% of the oil getting into the oil wiper case. Therefore, meaning that the scraper ring that follows that has to do less work. And you can see here we have then used a hybrid ring, and this is a design peculiar to Burckhardt. It consists of two elements. So we have a thin bronze ring, which conforms to the rod nicely, and that is then held in place with a PTFE element. The PTFE element also, as I say, holds that bronze ring in place, which has a very sharp scraping edge to it. So it keeps that in the correct orientation to the rod. We then follow up with a side-loaded packing. And this side-loaded packing is not to keep gas out of the crankcase, it's to keep oil mist out of the distance piece. Because if you get oil mist in the distance piece, that will then go around any oil flinger and then will still make its way to the main packings, therefore taking them out and causing premature failure. You will also hopefully be able to notice here that there is a slight chamfer on the inside of these rings. That is there so as that any scraping action that these rings do is only in one direction. We then move on to the intermediate packings. Here we have employed two side-loaded packings, and you will notice here that they are both in the same direction. Quite often you will see this arrangement where the side-loaded packings are in opposite directions. But in this case, the distance piece is purged, so we are ensuring that we are only sealing the gas in one direction. Now we move on to the main packings. Taking the operating conditions that Redura showed you earlier, we take these into consideration to design the number of rings, the type of rings, and the materials that we would use in a dry running packing. So following on with the manual from the original packing case, we looked at certain points. So for instance, here we take the number of cups that were in the original case, and we considered that. There was only a vent connection, so we have also considered that in looking to improve the situation. We have cooling here. There's only 2 cups cooled in completely enclosed cups. And then, of course, we have considered the sealing ring design. Again, now we have the manual drawing that we have for the main packing case, and taking the points that I have just mentioned, you can see that we have increased the number of cups available to us to help seal the gas, sorry. And of course, what that means is we get better sealing efficiency because we have more rings, but also we will get better longevity as well, so helping the maintainability of the compressor. We also have introduced a buffer gas into the compressor, into the packing case as well. So you can see we have the nitrogen feed in between 2 side-loaded packing rings. And then, of course, we have the vent connection where you have the mixture of nitrogen and process gas leaving the packing case. The cooling system we have improved. We have a lot more cups cooled. Also, the other thing that you may notice is that we no longer have enclosed cooling channels. So from a service point of view, this packing case is much easier to service and clean and make sure that those channels are free of dirt and therefore work efficiently. And of course, we looked at the sealing ring design. And I will go into the details of those particular rings in the following slides. So we start off with a pressure breaker ring. This pressure breaker ring has 3 jobs to do. So firstly, it protects the sealing rings from any dirt and debris within the gas. It also breaks down the pressure to help and also protect the subsequent sealing rings. Also, if the worst case happens and the rings fail within the packing case, the pressure breaker will help prevent any debris from going into the compression chamber and therefore causing further damage to valves, etc. So a very important ring. We then move on to a crown ring, and the crown ring is a mixture between a pressure breaker ring and also a seal ring. We use it for sealing what we call the dynamic component of the gas, or the pressure component of the gas, which constantly changes during the cycle. Then we move on to the seal rings, and here we employ a 4-element design. These rings seal the static component of the gas. And you may notice here we have a jointed anti-extrusion ring. So for those of you that wish to be able to assemble packing rings around the rod, we can design the sealing system to do that. But the preferred design is a solid ring because it offers more sealing efficiency in the end. So you may ask, why 4 rings? If we take a conventional radial tangent pair, we have the gas come along, it goes onto the axial face of the packing case, pushing it against the opposite cup face. You then get gas going up through the gap of the radial ring, allowing it to then provide a force onto the outside diameter of the packings, therefore onto the rod, and again helping to seal the rings. But you still get a little leakage. If we add an anti-extrusion ring, and normally these are used just to help prevent the packing ring material extruding down between the rod and the packing case, but here we're actually using it to help with sealing efficiency as well. So again, the gas that does it the same as it did before, comes round, but you now get less leakage through the sealing pair. Now, if we add 2 anti-extrusion rings, we get an even greater effect. So again, we're reducing the leakage through the packing case, thereby helping contribute towards achieving 0 emissions of this machine. So very important. Then within the vent and buffer, we're again using side-loaded packings. And of course, we use side-loaded packings here because you have very little differential pressure across the rings. So the springs therefore make sure that the 2 sealing faces remain in contact regardless the direction of the rod. One other point I actually wanted to make on a previous slide is here, one of the things that actually happens when we increase the number of anti-extrusion rings, we reduce the axial length of the sealing rings. And by doing that, we actually reduce the frictional heat created, which also helps with the longevity of the packing case and the sealing system. So at this point, I would like to hand back to Redura.
Thanks, David. So as explained by David in the previous slides, pressure packing was newly designed, which included also nitrogen buffer, and the distance piece was also purged with nitrogen. Now, in order to introduce and control the flow of nitrogen into the packing, as well as the distance piece, a local instrument board was designed, which included all the necessary instruments, control valves, and piping. This was carried out with detailed engineering by Burckhardt Compression. The complete project was concluded with a lot of engineering and documentation. Even though it was for another brand compressor, as part of the project, a complete user manual was prepared, which included the operation and maintenance instructions, spare parts code drawings, new P&IDs, new general arrangement drawings, and all the other necessary information of the revamp. Other documentation like quality inspection and test plan, certificates, data sheets, and all the required test reports were generated and handed over to the client. Summarizing the complete revamp, a comprehensive solution was provided while applying state-of-the-art design and technology. Not just the oil wiper and the packings, the complete cylinders were considered because the leakages were formed not just from the packings, but also from the valves, from the pistons, and also from the complete cylinder. So, along with oil wiper, intermediate and main packing, complete new cylinders with new poppet valves, piston and piston rings, piston rods, and automatically actuated valve unloaders were redesigned. Complete new motor and coupling were also replaced, not just from one compressor, but from all the machines, all the three machines. Sorry. Field service engineer from Burckhardt Compression was involved in the supervision of installation and commissioning of these compressors with the new components. The project was completed with the handover of all the final documentation. So what were the customer benefits? Customer was able to reap the following, mainly zero leakage. An audit was carried out by the customer after the revamp, and the results showed leakage rate down to 0. Thanks to the revamp, the compressors are in compliance with the HSE regulations. Compressors are now highly reliable. They are running now for more than 1.5 years without any stop. Compressors are fully complying API 618 specifications. With all the documentation provided by Burckhardt Compression, customer now has clear and detailed safety and maintenance instructions. The new state-of-the-art design and technology enforced by Burckhardt Compression for all the new components, customer can gain improved maintainability and operation of these machines. We were really grateful to receive a real testimony directly from the CEO of the refinery. In order to share this amazing case with all our customers, we have created a success story. And this is available on our website, www.burckhartcompression.com.
Thank you both, Redura and David. So let's remind again the three key takeaways of this TechXchange.
So you can see how we redesigned the existing packing into one that provides much better sealing efficiency and also longevity, and how the packings contribute to zero leakage of the machine and good environmental and safe working environment for the customer or the user.
The auxiliaries like local instrument board was designed in detail to control the flow of buffer and purge gas, showing that we focus on the comprehensive solution of the system.
Thank you. So let's have a look at the questions that came in the meantime. Feel free to ask your questions in the Q&A section, which you can find below on your screen. We have here one for Maddie. Did you calculate the loads of the compressor using the configuration of your new cylinder?
Yes. Before we even began the revamp, before we even designed the cylinders, we did all the calculation. We did the complete thermodynamic calculation of the compressor, which included the calculation of the loads as well.
Okay. David, how does having two anti-extrusion rings reduce the leakage?
Okay. If you hold both your hands up in front of your face with the backs of them facing you, and then you lay one over the other, if you imagine those as your two anti-extrusion rings, you then have, say, the rod going through the middle, and you have a slight gap around between the rod and the ring. If you then move, so in this case, one hand over one thing by one finger, then you could imagine that those two, the gaps in the rod, round the rod, are then covered one ring to the other. And that is how we believe that you get a better sealing efficiency by using two anti-extrusion rings.
Okay, another one for you, Dave. Did you consider the piston rod quality and coating on your design of your packing?
Yes, with any dry running system, it is a tribological system. So you have the gas, the material of the packing rings, or the compression and rider rings, and of course the counterface material, in this case the piston rod. And it's quite critical that you get those three things right to get a good lifetime. So we have to consider not only the coating that we use, say, on the piston rod, but we also have to consider the surface finish, because that is critical to getting a good run time and a good life out of it.
Okay, thanks. Another one, how long did it took the project, delivery times of parts, etc.? Madura?
There were 3 compressors we had to work on. The complete project took place between 8 to 12 months. I'm sorry, I don't know the exact time, but the installation took in a series. So they installed one machine first, and then the next, and then the next.
Okay, thank you. Another one from Redura. Why did the customer not decide to purchase a new compressor?
The investment cost for a complete new compressor was way higher than the revamp cost for the 3 machines. And you had to consider as well, if they had to change the complete compressor, we had to probably also look into changing the foundation, and there was also a lot of work. But the investment cost for the revamp of the 3 machines were way lesser than the investment cost for the complete one new machine.
Okay. There's another one for David. Would the same solution work for a lubricated compressor ring design?
Yes, it would. Within Burckhardt, we use a different design of sealing ring for dry running as compared to lubricated. So rather than using the radial tangent ring that we used in this case, we would use a 6-segment ring plus a radial ring for a lubricated, but otherwise the system would remain the same.
Okay, here's just another one for you. By having more rings in the packing, are you not increasing the frictional heat?
Yes, we do, but this was taken into consideration during the design. One, of course, we improved the cooling system within the packing case. And of course, by using the 4-ring system, we are reducing the frictional heat created in the first place anyway. So it all looks after itself, part of the design.
Okay. Let's see if there is another one. Just a second. I think we have answered all of them. Thank you very much. Just a second. Oh, there is just another one coming in. Let's have a look. What is the real lifetime of pressure packing on the basis of experience from operation?
That is a little like how long is a piece of string. It really does depend on the particular compressor stroke application, because there are small things that can make quite a bit of difference to how long you get. So as Redura mentioned, with this machine has been running for now 18 months on a dry running hydrogen compressor with dirt and debris, nasties in the gas, H2S, and that in a lot of cases would be quite a good lifetime. If you then had completely bone dry, clean hydrogen, you could maybe be going 3 years. So it really does depend on the particular situation.
Okay, thank you. thank you all participants for their interesting questions. This case was a good example of a very successful cooperation with a positive result for both the customer and also us as the service provider. Please note you will find the recording afterwards on our TechXchange website. Feel free to also share that site with your colleagues. They can register their contact details to get more information about our tech exchanges. We will send you the link afterwards, also together with a short feedback with only a few questions to see if you liked that session today. Thank you very much for taking the time, and we hope to see you soon again. Have a great rest of the day.
Thank
Goodbye.
you very much for listening.